Hello for everybody who's coming in. We're letting the participants roll through and we'll be starting really soon. And welcome everybody. For those of you who have been here before, thank you so much for this one. Will not disappoint. It's a fascinating topic. I was learning a lot about it when we were talking with our two presenters beforehand. And I've learned much more in that, half an hour of our conversation than I did in all the textbook time of my time in undergrad. And for those of you who are new here, welcome to like the 9th or 10th by now, Healthy Building webinar series. We started this when Michigan was going through quarantine, and to help answer those difficult questions, those literally unprecedented questions in global pandemic about how to manage your building and maintain it during this time, whether you're shut down or tenant relationships, or now that things are opening up more and you might have stagnant water in your pipes, the dangers of that and what you can do about that. Because of all the things that are on your mind, lest this not fall through the cracks. We want to thank Whirlpool very much for sponsoring this event and for connecting us with Purdue University to have these conversations. I'll come to the next slide real quick. I'll go to the next slide. Thank you. So for those of you who don't know me and I don't know you, my name is Jillian Jam. I'm the program manager for the West Michigan chapter of the U.S. Green Building Council. And we have the honor of having Andrew Welton and Caitlin Proctor from Purdue University to speak with us today. Andrew has tons of experience in civil, environmental, and ecological engineering. And Caitlin right now is doing really awesome work in her postdoctoral fellowship. So we couldn't have better experts from the Midwest to talk about this. Thank you so much for speaking. I'm going to turn it over to Andrew, and I will be learning right along you participants as you're coming through. Before Andrew, you can go ahead and share your screen, but before I forget, folks who are on the line, remember that you can use the chat to communicate with us and submit your questions through the Q&A. We're really active on that, making sure that all of you are heard and the dialogue is continuous. As the questions come up into your mind, don't wait till the end, just pop them in the Q&A right there and we'll make sure that your question is answered. At the end of this, you're going to be receiving a survey. Basically, what did you think of this one? Is there anything else you want? Technically, if you have technical issues. And we're going to make sure to incorporate your feedback for the next one. So thank you again very much, Andrew and Caitlin, for speaking. Please, Andrew, take it away.
All right, thank you so much for the invitation. And I am going to kind of kick us off and then pass it off to Dr. Proctor, and we'll talk to you a little bit about building water quality. So there we go. First and foremost, I just want to give you a heads up about something. There will be a Purdue University survey for building owners and managers coming soon. It's going to be an online survey, and it's basically going to be looking for what information do building owners need about their water systems, their pipes, their tanks, their devices in their building. What do they want to know? What do they need more of? What building owners are doing. So what are different people doing? What are different people in your community or across the state doing? And as well as where are they receiving their information? There's a whole host of different organizations out there that are putting information out nowadays. And in order to understand how best to help building owners, it's important for us to understand where people are getting their information. So the survey will take about 10 minutes and it will be online. It will be anonymous. And so it will be posted at plumbingsafety.org next week, which is the Purdue University website, and probably sent out by the USGBC Michigan. So if you have any questions about that, contact us. We're looking for an amazing response rate for amazing building owners, and we would love to have your feedback on it. Now, just to kind of give you a little bit of introduction about who we are and what we do. So at Purdue University, we have this organization called the Center for Plumbing Safety. It was created by the awarding of a $2 million research grant on plumbing safety to Purdue University and 5 other universities. And what we basically do is we help building owners, we help health departments who help building owners, we help the state, Michigan and other states who help building owners, and we also help federal governments and contractors. And we do on-site education, we'll fly into certain situations, we will put on workshops, free workshops for the public and building owners. We also do testing like a standard research operation. We have laboratories, we have nearby field scale testing laboratories, and in the upper right hand corner is an image of the Whirlpool Renew House. And so Whirlpool Corporation and Purdue entered into a partnership several years ago where they took this house, but they gutted the inside of it. And so they put all new plumbing and electricity, electric components inside there. And it is the most monitored home in America. You can tell where the water is moving at any point. You can track it going through the wall. I mean, it's really amazing. So that allows us to sample that building and know exactly where that droplet of water went, how long it's been in there, so that we can back out why the water quality is what it is. And we also do on-site testing and technical support. And we're headed out to a school tomorrow, actually, to help them get ready for their school year after 3 months of stagnant water. There's more information here at plumbingsafety.org, and you can just go there and take a look to see if any of that information will help you on other topics. And we also have COVID-specific topics. Dr. Proctor and I taught a course this summer, 1-month course on building water systems, primarily for undergraduate students, but we're getting ready to roll out a public health officials course to help health officials kind of get a common foundation for what building water systems are and how to take care of them. I put this timeline up here primarily just to show you that this may be the first time you've heard about us working in building water systems, but we've been pretty involved for quite some time now. And if you see all the logos there, we've tried to work with a lot of different groups who have expertise that we don't have, but benefit the community of building owners and managers and health officials. And so there's just a number of different activities that have happened in the last just 3 years alone. And we've tried to help move a lot of those forward. Copy of this presentation will be posted at plumbingsafety.org, and we're also providing a copy to the USGBC just in case they want to send it out or get requests for it too. So that brings us to the pandemic. And the pandemic, because of physical and social distance, prompted low to no water use in over 5.6 million buildings in the US. And that's because in these office buildings or municipal buildings or schools, everybody was sent home. And what that means is that all that water that typically goes through that building is hanging around for a lot longer. And this water generally is coming from public water systems. And so from public water systems, we have generally receive water through water pipes beneath the ground. They go through what's called the service line. They go to a water meter, and then they go to a property service line, and then into a building. And so these buildings, if you live in a commercial district in downtown Detroit or downtown East Lansing, maybe there's a whole bunch of buildings that haven't really had much water flowing through them. And so all that water that's typically moving through these pipes buried beneath the street has slowed down too. And so that's getting older. And so we're really concerned about old water because that's the water that accumulates more chemicals and microorganisms and also causes a number of other things to happen that Dr. Proctor will talk to you about. When visitors or building occupants are in the building, they may see different fixtures. And I just put this up here just to make clear what plumbing is. And plumbing isn't necessarily all sight unseen. Some of it is where you have to go into locked doors and go into utility rooms and see water softeners like the 2 yellow tanks you see up there at a school. Or you open the cabinet door and you see under sink filtration, or the things that you're used to seeing, which is water fountains, electronic faucets in bathrooms, and kitchen faucets in break rooms. So a lot of plumbing you've seen before, but what you haven't seen probably is more complex systems. And this generally is behind the walls between multiple locked doors, primarily because it is not necessary to go in there, and the buildings generally, right, this isn't a museum, so you're not showing people your amazing stainless steel piping and tanks. But I show you these pictures because they're complex. And the complexity of the plumbing depends on the building. So if you have a apartment building up on the right-hand corner, those are water heaters connected with copper pipe, and each of those water heaters goes to a different apartment complex, apartment unit. If you have industrial facilities or food prep facilities, you probably have a lot of stainless steel, you have a lot of valving, and the way that you tackle both of those buildings to try to get them ready for use or to get the old water out is very different. And this goes for colleges and universities, which may have hundreds of buildings, hotels, motels, casinos, and more. And before the pandemic, I just want to show you this result here. We went to a lead school and did some testing before the pandemic. And what we found was that there was a direct relationship between the length of copper pipe and the copper concentration in the water inside the building. And what we see here is the red line is 1.3 milligrams per liter. That's a health-based limit that the US EPA sets. And anytime you see a dot above that line or on that line means that there's a problem. And what we saw here is that this school had been operating for about 7 years, and over time, copper leaching decreases. So it probably was a lot higher when it was built, but it never been tested. And generally what happens with buildings is when we build them, we don't test them typically. There is a stipulation in one of the plumbing codes that a general bacteria test be conducted, but there's no lead testing, there's no copper testing. And so why I bring this to your attention now is because some of the buildings that are actually probably being used now may actually have water quality issues that we don't know about. And so as you go out and try to address issues today, you may find that you find something, and the only way to know if it was before or after the pandemic is to really continue to drive in and figure out what's going on. And finally, before I pass it off to Dr. Proctor, the issue we're talking about here is stagnation. And so stagnation is basically water sitting still, marked by lack of flow or movement. And the CDC, the nation's public health authority, has identified that this can be a problem. And Dr. Proctor will explain why.
All right, let me just share my screen here. So because we were concerned about stagnation, we initiated a number of parallel efforts that are trying to get at why stagnation might be an issue and what we can do about it. So one of our first efforts is to support plumbing and public health sectors on water safety guidance and decisions. So we've been taking a number of calls from public health departments, for example, to keep them informed. We're reviewing we created a review study on prolonged stagnation together with experts from 7 private and public sector organizations. This effort continues as we all are working on this. We're doing field testing, as Dr. Walton mentioned. We're going out to an elementary school tomorrow to see what is happening in the field, and we're in a number of buildings right now to quantify the impacts of this long-term stagnation. We're initiating some lab tests to more fully understand the mechanisms of these, and we're really helping to transform public awareness with webinars like this. So our review effort that I mentioned is now published in AWWA Water Science and is available free for download. This was a very rapidly completed review study. We completed it in about 1.5 months when this kind of study usually takes at least 6 months. And we had really the top experts from all over the world contribute their thoughts on what is happening in buildings and what might be a concern and what we might be able to do to prevent these kinds of issues. Now, one of the major takeaways from that study is that water safety in commercial buildings is complex in part because commercial plumbing is complex. There's so many factors to consider, and each building has individual characteristics that will influence the risk in that building and influence what is happening in that building. For example, your water source could be a municipal source where it's delivered with chlorine or with chloramine, and each of those different disinfectants will have different impacts on the water quality. Or you could have on-site wells where the building owner is responsible for water treatment. Service lines carry water from the municipal property of the water pipes under the ground, the water mains, the water laterals. And these service lines can be very complex. You would think that it would be a straight line, but from the street to your house, but we've seen that it can go in all sorts of shapes and take a long time to get water from the municipal source to the building. There's lots of safety devices and valves like backflow prevention devices. There could be water treatment devices within the building. We're in Indiana, where there's a lot of water softeners that are in pretty much every single commercial building. Water service, distribution, piping, and faucet connectors can all be made of different materials. The hot water system is another complex beast. Your water typically divides into cold water pipes and hot water pipes, essentially doubling the amount of pipes that are in your building. In commercial buildings, there might also be on-site water heaters or, point-of-use water heaters that will instantaneously heat up the water. Or there could be recirculation systems that keep a large volume of water warm for a long time. Recirculation systems tend to have more issues because the temperatures drop in those systems. There's just all sorts of things in plumbing, point-of-use devices like filters that go onto the end. All of these need to be taken care of, especially during long-term stagnation. So what actually happens during stagnation? When we are in a building that uses water normally, the water coming from the municipal main typically carries disinfectant residual and corrosion control. Every time we use the water, that disinfectant residual and corrosion control comes into control reactions that are happening that can increase metals and bacteria in the water. While there might be some stagnation, for example, in office buildings over the weekend, when we bring that fresh water in on Monday, those issues will be controlled again. And this is a cycle that goes on and on. However, during the pandemic, we had really long-term stagnation. So water was not refreshed, and this disinfectant residual and corrosion control completely disappeared. We don't know exactly what will happen in these pipes, but we're predicting that there will be bacterial growth and that corrosion will no longer be controlled. So these reactions are something that we're studying in the lab and something that others are also studying concurrently during the pandemic. Now, not all of these reactions are problematic. Not all bacterial growth is going to cause a health risk, but there are certain things that we're concerned about. First, copper can leach from pipes, especially if you have copper pipes in your system. As Dr. Walton mentioned, copper above a certain level will cause short-term acute healthcare risks like nausea, vomiting, diarrhea. Lead can also leach if there is lead pipe, or if there's pipe that contains small amounts of lead, or if there was ever lead in the system that might be in the scale. This, as we all know from the Flint, Michigan crisis, causes a number of problems. When corrosion control is no longer in the water, scale can be suspended, so these long-term problems can get much worse. We're also worried about the growth of specific harmful organisms. For example, Legionella pneumophila and other opportunistic pathogens can grow in stagnant water, and these opportunistic pathogens cause a respiratory illness, a pneumonia. And actually there was a case recently where a pneumonia was misdiagnosed as COVID, but it was actually this bacterial pneumonia, and the treatment for these are quite different. Now, because these harmful organisms cause respiratory disease, the exposure routes are not just through drinking. It's also through any inhalation activities like showering, where we might inhale the bacteria and they can lodge in our lungs. Now, a number of public health departments and other organizations are trying to get the word out about these potential issues. And since March, we have counted more than 45 different guidance documents telling building owners what they could do to prevent and deal with stagnation issues. These are coming from different state organizations, local organizations, and we've noticed that they differ dramatically. For example, some say flush for 30 seconds, and others say flush for 10 minutes, and others don't give a time. Some lack key information about safety devices, about sensitive populations, or don't explain why these actions are actually needed. So why are they so different? There's just a lot of different perspectives out there about what is needed to be done for water safety. And there's different starting information about safety and plumbing. As we've described, plumbing can be very complex. So if you don't understand that there's many different devices in the systems or many different types of piping configurations to deliver water, then you don't necessarily understand how to advise people on these issues. Guidance is targeted for different readers too. So each reader is going to have a different level of understanding of water systems, and there perhaps need to be more targeted messaging for each of these groups. Some are, step-by-step documents that a facilities worker could use to walk through the building and complete actions, but others are just general advice that say, oh, you should flush your toilets more often. That's not exactly as useful. There have been several revisions on these, including some that we have given input and advice on, and other organizations like the media have given even briefer messages that don't take into consideration all of this complexity. So what can we do to prevent water quality problems? One of the things that we have been suggesting is to keep the water moving and prevent stagnation in the first place. But this is a little bit more complex than it sounds. Source water has to be fresh in order for any flushing activities to be useful. So if you think about a district, like for example, a shopping mall district or another commercial district that has been completely shut down, the stagnation issues that are occurring in individual pipes and buildings are also going to be occurring in the buried distribution system in those districts. So in these locations, there might be a need to communicate with the utility to make sure that the source is fresh and has disinfectant residual. Cleaning devices and equipment might also be needed. So water heaters, for example, can be drained and cleaned. Sometimes you might want to have more professional advice on how to do that for your specific model. Flushing in order to keep the water fresh sounds pretty easy, but you want to be sure to do that in the right order. You don't want to flush at your furthest point, not flush for long enough, and not get fresh water all the way to that point. At that point, you're simply moving dirty water around. So when we have a couple of YouTube videos available to help you figure out how to create flushing plans for your building. And one of the major points is that you need to start at the source, start where water enters the building, establish fresh water there, and then move through the building so that you're not moving the dirty water around. Recirculation loops and water heaters can also be problematic. The temperatures for growth are really key for organisms like Legionella pneumophila. And one of the best pieces of advice is to keep hot water hot and cold water cold. It's when water gets into this middle ground where water is, not quite hot and not quite cold. This is when bacteria love to grow. And of course, a good idea is always to document the actions that you're taking and make sure you keep track of how often buildings have been flushed, how much they've been flushed, and if you're testing, what the test results were. So if you haven't been able to flush, during the pandemic, there might be a different set of actions to deal with water quality deterioration after the fact. This is a process we refer to as recommissioning plumbing. When you come into a new building, there's an entire process called commissioning where you have to make sure that the pressure is stable and that water quality is good enough for use. And when you're coming back into buildings that haven't been used for several weeks or months, recommissioning might be needed. So system integrity checks are important to make sure that all of the equipment is working properly as it should, especially if eyes haven't been on it for several months. Flushing, like we talked about before, can also be done to move the old water out of the system. In more extreme scenarios, shock disinfection might be needed. So this is when you increase locally the dose of disinfectant residual, like chlorine, in the pipes in the system. For that kind of action, you would want a plumber on site who can handle the chemicals that are needed. And testing might also be needed to ensure that water is safe before people start using the systems. So professional help is definitely recommended for some of these actions. Complex mechanical and treatment equipment might need specific advice from the manufacturers on how to deal with those specific stagnation issues and how to handle that equipment. Effective flushing plans, you might need an expert to help you do that. The important thing with those flushing plans is that you need to think about everywhere that water is used. So not just the faucets, but all of the showers, all of the outdoor irrigation systems, the toilets, the places where people get water for coffee. All of these need to be addressed fully in order to have safe water in the system. Shock disinfection, whether with high doses of chemicals or high temperatures to kill the bacteria that have grown, would also need professional help. And then performing accurate testing is also best done by professionals or in professional labs. And with that, I'll hand it back over to Andy to talk more about some of these issues and what needs to be done in buildings. Andy, you're on mute.
Sorry about that, talking to myself. Thank you. A couple things to pick up on. Is this really a big deal? Yes, it is. And there was a study that CDC was a part of the other day that came out. It was done before the pandemic, and they found out that at a hospital, 2 toilets were contaminated with Legionella, and 2 patients got Legionnaire's disease, but none of the drinking water faucets or showers had Legionella in them. So just because it's not a faucet doesn't mean that the water in the device doesn't pose a health risk. This is one of the reasons why people recommend flushing toilets. You know, don't forget the toilets. Make sure that the toilets are flushed, the sinks are flushed, and the like. And so that brings us to flushing. In more intensive cleaning that we do for plumbing can sometimes make people sick. So if you have a stagnant building, like one of the ones that we're going into tomorrow that's been stagnant for 3 months, according to OSHA, we need to wear N95 respirators because Legionella can be aerosolized or basically put into the air when contaminated water comes out of a faucet and splashes. And so to also kind of prevent this from happening, we are going to do a whole number of different things, you know, covering faucets to reduce splashing with plastic bags, maintaining pressure, and then but paying attention to flooding and cross connections and all the waste that we generate. You know, there's another action that can be done too. If the parts of the building or the entire building has gone unused for 3 months or many months, you may want to temporarily forbid use of that area to high-risk populations. I know gyms are doing that in some states where they're not having showers be used or hot tubs because they know that they're not going to be used much and they don't want to have to keep up the maintenance and put the labor towards that effort. And so there's just a number of concerns and considerations that have to happen. Earlier this week, a report came out, as Dr. Proctor mentioned. A patient went into the hospital 4 times. He was tested for COVID, and 4 times it came back negative. It turns out that he has Legionnaire's disease, which you can only get from contaminated water. So in this news segment here, he talks about how he works at a hardware store, and the building had been shut down for a while, and he came in and was doing a lot of cleaning. The health department is investigating the exact source of it. Yesterday or 2 days ago, there was a statewide alert by the Pennsylvania Department of Health, the public health authority for Pennsylvania, to all hospitals and healthcare facilities, basically warning them to start paying attention to potential cases of Legionnaire's disease, which is specific to this bacterial pneumonia that you get from contaminated water use or being in the proximity of it. And so, so there are health officials that are taking concerns with this. And, and as building owners, what do you do, right? So if you've already started opening your building or you're already back in it, and you haven't contacted the health department yet, specifically the environmental health group, that's the division, you may want to reach out to them and ask them if they have any specific guidance on what you should be doing during this time. And many health departments came out with their own guidance. Some health departments saying the CDC's guidance down in Atlanta, which is not necessarily prescriptive enough for you to do what you need to do, but you'll get some idea about what other building owners are being told in the community in your state. You should contact your water supplier if you receive it from water off your site and ask them what they're doing. If you have concerns, you could ask them to do more testing maybe in your area. They won't come into your building, but they'll go to the hydrants and other places around the area to do testing to keep that water fresh. And the other issue is don't let water sit, right? So in normal building operation, you kind of know what that is, how many people generally come in, which bathrooms are used the most. And if we just don't let the fixtures be used as much, we have to do something about that. So we've got to keep that water moving. And so flushing programs, maybe the administrative assistants or the building maintenance staff go in periodically and keep that water moving through the building daily or at least 2 to 3 times a week. And then test temperature and disinfectant levels. This is inexpensive. I'll talk to you about that in a second. And create and maintain records, right? So if you do ask an administrative assistant or building maintenance staff to start inspecting fixtures or go into certain rooms and turn on the fixtures for a certain amount of time period, start writing that down, because that's going to help you basically understand what's happening to the building water system. And they'll be able to write notes, water was yellow, water was red, and then that may indicate that, okay, the water is getting really old in that part of the building, we have to do something about it, flush it more. So what could your day look like? Just to kind of give you some update as to, we're going into a stagnant school, 3 months water sitting there. What are we going to be doing? Well, we had a pre-visit and we went and looked for as-built construction drawings that show pipe layouts. They don't have any. So there's no record of where the pipes go in the multiple buildings that we're going to go to for cold and hot water. That's going to be challenging. We went to look for where water enters the property, which has multiple buildings, and then from there, where do the buried pipes go and enter the building? Well, as it turns out, there is a water meter, but we don't actually know where the pipes go and where they enter the buildings, because the person who built the buildings, I think, walled in the shutoff valves inside each building. So that's going to be challenging. But these are things that you should be looking for. And then where you find that location of where the water enters the building, that's where you start your flushing. We walked through, we looked for all the devices and fixtures. They don't have any hot water recirculation loops. They just have water heater tanks, which is good. Hot water recirculation adds complexity. And so then we asked the utility to keep water fresh. We're going to be back to this building on Friday. Please make sure that fresh water is out underneath the street so that when we start flushing the building, we bring in fresh water. Flushing visit, we assume that Legionella is present, even though we have no evidence that it is. So because we want to protect our workers. So we're going to be wearing N95 respirators, goggles, and skin protection. We're showing up with a thermometer and a disinfectant residual kit. It's about $200. Tells us what the chemical level is in the water. We want disinfectant in the water, so we expect to flush and bring that fresh disinfected water into the building. And then we're going to flush the campus service line. So we'll go to the water meter area first. We'll track that line all the way to the first building, and we'll start flushing that building to try to bring in fresh water into the campus and then go into the first building. We're going to remove the aerators, clean them in a dilute bleach solution while we're flushing. Flush at the point of entry. For cold water, we're going to march through the building, and then we're going to go all the way back to the beginning of the building and start flushing hot water. The reason why we're doing that is because we don't want we want to completely purge the cold water system and then completely purge the hot water system. We don't want the systems mixing because it'll be hard to figure out if we've flushed enough. We do need to flush the water heater. A good idea is to shut it off, or you could flush it full and just measure temperature, and that will tell you when the hot water starts coming out really cold, you've basically turned the whole thing over. Reattach aerators, run the ice makers and the coffee machines 3 times, throw batches of dirty water away, and then we're done. So when we're going to leave that campus, we're going to tell them, flush your fixtures maybe 2 to 3 times per week. If no water use in the building, less if you plan to use that water. And then what should you look for? Well, water use records, how much less use has occurred. Are there any floors or locations in your building where less use has occurred? Did you close any bathrooms or parts of the building? Are there any devices? When's the last time you changed the filters or the water softener? Did you clean it recently? You can test for water temperature and disinfectant residual, which is relatively inexpensive. And then we've had a lot of questions about, should I test for XYZ chemical or organism? And our response always is, you need to know what you're going to do with that information, and you need to be testing at the right location. So for example, if you find copper in hot water above this EPA safe limit of 1.3, it actually doesn't matter because nobody should be drinking hot water. So that's not, the only way you would have exposure is drinking that water at that level. And so you need to basically walk through the process of where you're going to test and such, not just take samples. Education is what we do at Purdue, and we set up courses. You can go online and watch these very short YouTube videos about why flush water systems and what that might look like. And we're also creating a short course for public health professionals soon that will look at basically giving people a foundation for what building water systems are, factors that you should look out for, and then how to intervene after there are problems discovered. So in conclusion, thanks to the USGBC for the opportunity to talk with you. We're happy to answer any questions. Keep that water fresh. And the only way to know sometimes if guidance works is to test if you're in that situation where the water's been stagnant for a really, really long time. So thanks a lot, and we're happy to answer any questions.
Thanks, Andrew. And thanks, Caitlin. This is kind of when the time I would ask everybody to give an applause. So just a little applause from me to you. Thank you so much. We're going to take over and have our slides shared. In the meantime, there were some questions who came through. There was one, Christian says, buenos dias, Christian. Muchas gracias también dice. He also says, muchas gracias. Which, is there a way to get these, this is just a question that just popped into my head. Is there a way to get these, you said 45 plus manuals available around everywhere that you've looked, and your information? Do you find that these are multilingual documents?
I think there's been some public health departments that have tried to put general awareness documents in, Spanish or other languages, but I'm not sure, and that's definitely a gap that needs to be addressed.
Absolutely, because I was thinking for myself on, we have some Hispanic businesses who are really involved with our programs, and we make sure that somebody bilingual is always there to speak with them, in kind of either English and Spanish if they need it, or vice versa. And that's what we as an organization do. However, bandwidth is limited in these sorts of things, especially now. But that doesn't change the fact that this danger is universal in building owners. For instance, there's some restaurants that have been closed for a minute, and we've been trying to find ways to reopen them safely. This is key to have this information available to them. Have you seen any creative solutions to being able to have this information accessible in someone's language?
I have seen some documents that were put out with pictograms for your home that had water shut off. So a home that has water shut off that was turned on for coronavirus hygiene, for example, will have the same issues, But dealing with those issues in plumbing is a lot, and plumbing of like single family homes is a lot more simple because basically because the buildings are smaller, there's, you know, pretty simple piping that's pretty standard across residential dwellings. So I've seen some efforts on that side maybe to have, you know, at least pictograms that can, you know, say very simple language like flush for 30 seconds. But that kind of, you know, flush for 30 seconds, very simple advice isn't necessarily applicable to all of these businesses and commercial buildings. So that's a gap, and we need to address that in the field. The problem is that most of these documents are being put out by public health departments, and the person who's normally on water is on COVID. So they don't have the bandwidth.
Yeah, absolutely. I've been really proud of Grand Rapids for seeing how they've creatively tried to fill that gap, but that gap is ever present. You know what I mean? And we need to get better about that. So I know that I'm going to be looking at our local health officials and see if there's the fixtures that you've recommended just now. So a question that had come in to just get the ball rolling was kind of from, I know that this person's kind of a DIY kind of building owner himself. And he had asked, can I get one of these disinfectant residual kits for myself? And if I'm testing them, what are levels that I should be worried about?
So Dr. Walton mentions handheld HACH kits, HACH. This is a pretty popular company that gives out reliable kits that will give you disinfectant levels. Now there's a few things to keep in mind. One is every system has a different, or could have a different type of disinfectant. So if your municipal system is a chloramine system, this is different than a chlorine system. So you want to be sure to be testing for the correct things. And it looks like Dr. Walton pulled up some links, so I'll let him talk a little bit about that.
Oh, I was just being your assistant and pulling it up so that you could keep talking about it.
Okay. So you can always contact your utility to see, you know, which kit is applicable for my locality. So total chlorine is probably the most universal, so that you can look at, you know, that whether you're in a chlorine system or a chloramine system. And then levels to worry about. So it is not uncommon in buildings to have zero detectable disinfectant residual, especially in that first flush. Yeah. So when we studied at the Renew House, I think we only saw disinfectant residual about 10% of the time coming into the building. The rest, the disinfectant was non-detectable. But what you do want to be concerned about is that after you flush, after you think you've brought fresh water into the building, you should have detectable levels of chlorine or chloramine. And 0.2 or 0.1 milligrams per liter is a common cutoff for calling it detectable. And above that is probably acceptable.
Milligram per liter. Okay. But you said the first flush sometimes isn't detectable. Sorry, isn't detectable.
So there's reactions within the pipe. There's organic matter, there's bacteria, and all of those reactions, chemical and biological, are going to consume the disinfectant residual. So the longer you let water sit, the less likely you are to have this disinfectant residual. And that's when all of these problems occur, like the growth that is uncontrolled.
So then when someone like flushes their system and then checks it, they're like, we're good to go. But probably like a week or two down the road, that might be different. So do you recommend like a timeline that someone should adhere to as well?
So even a few hours later, that first draw might be completely consumed.
Like quickly.
Yeah, so you want to be sure that you understand which water you're testing. If you're testing a first flush coming out of the pipe, then don't necessarily expect that you're going to have a high detectable disinfectant residual. But the water that's coming in fresh should have one. So definitely these, you know, recommissioning actions, flushing needs to be done regularly. Different organizations are giving different frequencies. One paper I read, in order to have Legionella completely controlled and acceptable levels, and this was in a hospital where they were really concerned, you needed to have water moving every 2 hours. Now that's a bit extreme, and it's not going to be done in all these commercial buildings, of course, but you know, after the weekends, you're not going to have disinfectant residuals. So, you know, maybe every 3 days or every, you know, week is something to consider for how often to flush. Yeah.
Just one thing to add too, in terms of like, oh my gosh, do I have to do this complete water heater flush out and drain the plumbing and take off the aerators every 3 days? No, that's kind of like the big clean out, right? You just basically clean out your plumbing and do maintenance on it and try to bring it back to new as possible. And then you do this maintenance stuff, whereas every 2-3 days, or maybe the janitorial staff come in and they run all the faucets as they're in each room and just leave it running for, you know, 5 to 10 minutes or something like that, just to try to at least simulate something happening, because we don't want the water in the pipes to turn into pond water just sitting there until the next person uses it.
Ew. The question that came in says, understanding that stagnant water poses the biggest risk, but even without stagnation, should we be testing our water on a regular basis? And then it says, if so, how often would you suggest?
You can try to answer, Dr. Walton.
Yeah, so bottom line, you know, and I've kind of mentioned this before, we went to a school that had very high copper, and they did lead testing only, funded by the state. And this state gave them a clean bill of health and said, congratulations, basically your water's safe. And we showed up. Actually, we found widespread Legionella contamination and copper contamination in this school that was 7 years old. And so the school superintendent said, well, how did you find this? And we said, well, you didn't have your water tested when you started the building, so you didn't know. And number two, Legionella doesn't just leach out of pipes. It comes in from the utility at some point and then grows and takes time to grow. So the superintendent said, well, nobody told us. And the answer is, well, yeah, that's true. Nobody told you. And the engineers and architects don't require it because it's not necessary. And sometimes building owners don't want to pay for stuff that's not regulatory required. So where we are today is you may have a building that's fine, that doesn't have high lead, that doesn't have high copper, that doesn't have Legionella or any other pathogen, or you may have one that has it and you don't know. So the issue is to identify the relative risk. Do you have components in your building that may have potential for this? Do you have that one bathroom at the end of the second floor that nobody really ever uses because there hasn't been a tenant there in 6 to 9 months? Well, okay, so that might be an issue. These are things that you have to walk through, and unfortunately, the engineering and the other communities and the public health communities really haven't helped building owners with that because they've had other priorities. That's really why you're just hearing about this now. Caitlin, did you want to add to that?
Yeah, so testing isn't always embraced by building owners because it might introduce liability. If you know about a problem, then you have to do something about it, and that can be an expensive process. So I think it's the responsible thing to test, but you also really need an expert to help you understand the results and understand where to put your resources. It's not going to be like, if you're looking for Legionella, you don't want to get maybe the most fresh water directly from the main. You want to get target specific locations that are more likely to be contaminated and more likely to be exposure points. And an expert can help you understand that there's differences in your building. What you see at one tap is not what you are seeing throughout the whole building. So there are people available to help if you're interested in testing.
One other mention. So if the way that buildings are designed today and the products are tested is not representative of how the buildings are used before the pandemic. And so we've taken products that are installed in buildings that are tested, that are certified with appropriate procedure, and they've failed our test. And the reason is because we apply very realistic, this is what happens to water in buildings. And the way products are tested to get into plumbing that engineers put in there are not tested realistically. And so when you have a builder build a building and you say we're going to do testing, well, under normal conditions, that product may fail, but under the conditions that it's designed to succeed, they can build the building and walk away from it. So there's a whole bunch of issues here, complexities. That's not just water quality, it's how buildings are built and products are tested to get into buildings, and engineers create them and architects create them and walk away. So if you're a building owner and you're really confused about what's happening, I'm sorry, this is how the system's been set up. We're happy to help you, and other people are too, in working through the process.
It really struck me when you had said that, maybe I'm going to say this incorrectly, so please help me out, but when a new building is made, and then the leaching decreases over time. But so right when a new building is made, that's when the leaching is going to be the most, and then into the water. And then after that, it'll decrease. Did I understand what you had said correctly?
Yeah, theoretically that happens. But if you have changes in water quality, you can have like scales that form, like sediment or iron or lead or copper form on the pipe. If you change that water quality, like you just let it stagnate or you put different water into it, you have those scales come out, kind of like what happened in Flint to some degree in concept, and then the water quality you can have things increase in the water too. So it's really complex. In general, for example, new copper pipe leaching decreases over time because the surface gets coated and copper doesn't come out. But if you have these changes, you can cause high releases of that material to come out. Sorry, Dr. Proctor.
No.
You were going to say something?
That's fine. You covered it.
That leads well to this question that had come in. It says, Dr. Welton mentioned copper leaching contaminants. Which piping is safer, copper or PEX?
So I laugh because that's the $1 million question. Yeah, I don't know what's safer. It depends on the source conditions. For example, if you have like copper pitting in your area, installing copper pipe when you know that it's not going to last more than 5 years is probably a bad idea. So there's other considerations. You know, the mechanical failure and leaks and insurance claims would be considered. Copper ages over time, so the surface gets coated and less copper leaching comes out. PEX also gets coated. We had a study showed that. We exhumed actual PEX pipes from a building and found out that what's in contact with the water isn't PEX anymore. It's all the sediment that accumulates on the pipe that is in contact with the water. So the verdict's still out, I think, on which is better. There's different reasons for selecting different technologies.
And Dr. Proctor, I saw that you had an expression too. What do you think about that as well?
It's different threats from different pipes. So at some point, you know, we think of plastic pipes as being worse for biological growth, and copper pipes might be worse for, you know, metals issues. So,
So you're talking no silver bullet? No.
So
there's not even a silver bullet for flushing plans. Like each building is individual, each water quality in each locality is individual. And that's something we're hoping to better understand through our scientific work, but there's just so many variations and uncontrolled factors.
There's a question that came here. Do regular filters, then parentheses, or some types of filters help remove the threats you're talking about? Do filters help?
I'll talk lead and copper. So there are filters that are certified to remove a certain amount of lead, not forever lead, right? So 20,000 parts of lead. Filters are not designed to remove 20,000 parts per billion of lead or 1,000 parts per billion of lead. They're tested under certain conditions, which is what I go back to. The products that are being used today are not necessarily tested for the applications that they are being used for. You actually have to know that and do testing. For copper, the only way to really remove copper is reverse osmosis or ion exchange, but copper and lead, like copper is just not the only thing in water. There's other things that compete for that filter's time. And if you saturate that filter, everything else gets through. So that's an issue. And nobody's really addressed this yet. There's standards out there that indicate that certain filters are good for certain things. But what you're not told is there's no sign on that filter that says only challenge this with 15 parts per billion of lead or 50 parts per billion of lead. Don't use it if you have 55 or 100. And that's one of the issues with that building owner's face is how do I know that this filter is going to work? And well, what conditions should I not use it for? So Dr. Proctor?
Right. So, each filter is designed for specific tasks, and you want to read carefully about those tasks and also about the maintenance that's required. They give, recommended replacement times that are very important to adhere to because the filters do go bad to an extent. There are biological filters that are designed to remove Legionella or other bacteria. Not all of them have been tested in super realistic scenarios. And then there's always the issue, wherever your filter is, there might be growth after that filter. So if you have a filter at the beginning of your house or your building when it comes in, that doesn't really protect what issues might develop downstream of that. Even if you have a point of use filter that's built into your shower hose, there still could be growth after that shower hose, like in the nozzle area. So it's just important to consider where the filter is and, when's the last time you replaced it or checked it. All those are important.
So,
and there is, well, just one thing about filters. So one place that we went to, they were trying to address their copper problem, and they hired a consultant who told them the wrong information to go out and buy ground activated carbon filters. So we showed up one day walking through and saw maintenance installing these GAC filters on their water fountains and asked them what they're doing. Because GAC doesn't remove copper. It's not capable. So, what you also have to do is make sure you're talking to the right people and getting the right information. And how would a building owner know that since that's not their job? I think you just got to do your homework, just like kind of letting somebody in your house to, fix your toilet or whatever. You don't want anybody in. Just because they exist as some organization doesn't mean that they're credible. That's something you have to watch out for.
My goodness, I have more questions, though unfortunately we have to be wrapping up soon. Man, I'm so tempted. But anyway, I guess maybe I'll email you. Will you please go to the next slide? I can't thank you enough, Dr. Proctor and Dr. Welton, for speaking with us today. It's been very enlightening for everybody on the call, as well as for me personally. I hope to be talking with you again soon. So for everybody on the call, you're going to be hearing about 2 surveys this time, bonus. So the typical one about, what do you think of this webinar? What more do you want to see? That one's the standard. Please fill it out. We really value your feedback. Also, there's one coming from Purdue University that is trying to assess what your current baseline understanding is of your building. As Dr. Welton had said that you don't have to be an expert in water piping. That's not what being a building owner is all about. But we want to understand where you start with that knowledge. And that'll help inform us about how to deepen our education with you. So as always, thank you very much to our visionary sponsors, Consumers, DTE, Eagle, and Wege Foundation. And thank you once more, Purdue University, for speaking with us today. And thank you for everybody on the call. So take care, everybody. Have a lovely day.
Thank you.
Thank you.